right, good morning. Welcome to my stream. Let's see if we can get going. All right, good morning. Welcome to my stream. Let's see if we can get going. Switch over here. There we go. All right, so where did we leave off last time? Oops. Okay, I think we're here. We're here. Oh, we want to check out where we were. So we just finished k closest points to origin. Did that. And now we're up to longest substring without repeating characters. Okay. Where's my mouse? There it is. Oh, I got a train in the background. I'll wait till the train's done before I start. All right, I think that's good enough. All right, longest substring without repeating characters. Let's, this is clean, right? We're clippy clean, and we're test clean, and everybody's clean. Okay, so, and get state just shows clean. Good, all right. Problem number 3, longest substring without repeating characters. Oops. Given a string S, find the length of the longest substring without repeating characters. Oh, that's all it is. Okay, so input is ABC, ABCBB. Output should be 3 because ABC is the longest substring. Here B is the longest substring without repeating characters. And then we have WKE. Notice the answer must be a substring. PWKE is a subsequence and not a substring. Okay, because it's a double W. All right. Well, let's get things set up before we come up with a solution. But this doesn't seem like it's too difficult. Let me just change the volume here again. It's a little too loud for me. All right, that's better. All right, so this is 0003. Right? Longest substring without repeating characters. That is very long. Is that the longest one we have so far? Oh, this is close. Let's see. I'm just curious now. That goes to 63. And that goes to, oh, so it's the same length. Okay. All right, so we try to build. We then do the quick action to create the file. We then jump to that file. We then grab this, copy, pub struct solution, paste, and return 0. And then that should also build. It does. I'm looking over here to see if it's building or not. And then we have our test. First example is going to be solution length of longest substring for, and it's looking for a string ABC, ABC, BB, toString, and that's going to be equal to 3. And that should fail. Oh, test. There. And it fails here. Good. Okay. So the first thing that comes to mind is using some sort of using a hash set in some fashion in order to keep track of what characters we've seen before, and then just keep a list of all the unique characters. So like if we add A to a hash set, and then we add B, and then we add C, and then we go to add A, but A already exists in the hash set. We can't just remove it and keep going. We actually have to remove it in order. Right? We have to remove, because once we get to this B here, right, well, it'll be A, B, C, B. We want to remove the A and the B from the substring, and it'll be CB. And then we want to keep track of the length of the longest one that we've encountered so far. Okay, so we know we need a hash set, because that's the way we're going to look things up. So use standard collections. Oh, I shouldn't be writing it here. I should be writing it over here. Use standard collections hash set. And then we'll need an array, which is s.chars collect vecchar. Right, so now array should have a list of all the characters, and we can actually go through each array element. So I guess we'll have start with a start and an end pointer, and then we move the end pointer forward until we find a character that we've seen before, and then move the start pointer forward, removing from the hash set until we've removed the character that we encountered. Okay, so our hash set is just going to be start off as empty. Kafka, how are you? Yeah, I try to stream around the same time every day. So if it's a bad time for you, then that's gonna unfortunately be a bad time every day. But glad to see you today. Let's see. If we start off by just inserting, we can do, so let's start and end values. Let's start equals 0, let end equals 0. And we can say while end is less than array len. We want to look it up in the hash set end, right? If HS contains array of end. Kafka says it's fine, just me being too busy. Yeah, I know how that goes. There are many mornings that I can't stream even though I want to, because of various life things. So if the hash set contains, all right, so we're going to assume that we've gone through A, B, C, and now we're on the second A, and we see it there. We want to remove the first entry from the array, starting with start until we no longer have it in the array. I guess, yeah, so what we can do is we can make this a while. While HS contains array end, we can say HS remove array, array start. VJ, thank you for the follow. Much appreciated. Glad to see you. And then start plus equals 1, right? And that way we'll keep removing until we hit the beginning, the first one that doesn't have array end. So now we'll have an actual array length. VJ says roses are red, violets are blue, lead code is cool, VJ follows you. Very nice. So now we want to save the length of the array. So we need a max len. And we want to say the length, I guess, is the number of characters in the hash set, right? So we can just say max len of max len dot max of HS len. Because the number of characters in the hash set is the number of, it should also be equal to start minus end, right? Oh, we got to insert HS insert array end, because we've just removed it, right? We just removed array end from the hash set. Now we're going to reinsert it. I guess that's kind of sloppy. Maybe it, but there's no other way to know it. Unless we say HS remove array start and then check to see if it's equal to array end, and then we can just ignore that insert. But that's starting to feel like premature optimization. Let's see if this version works. And then I think that's all we need to do. And then once we've figured out which one is the one that has the most characters in it, that's our result. Right? Oops. Okay. What else? That also has to be a reference. I keep forgetting that. And then this needs to be in I32. Is that it? No more items. Okay. And this fails because I'm off by 1. Nice. I'm off by 1. Oh, we want to include the end. Okay. So let's do that. How's that look? Yep, that looks better. And then, oops, example 2 is BBB. Let's see if that one works. For Y, paste. 1, 2, 3, 4, 5, and that should be a 1. Yep, that works. And then we have this one, whatever that is, PQQ. EX3. That one, and that should be a 3. Okay, so I think we have a working solution. We might make it a little more efficient by not removing and then inserting right away. But let's see how bad this is. I'm being judged. Okay, not too bad. 35%. Again, these runtimes are kind of wacky. All right. Can we actually do that? We can say, while HS contains, okay, so we don't want to actually do that while HS contains. If we don't want to avoid inserting the same character we just removed, we can say loop HS remove array. Doesn't the hash set remove give us Rust? There's too many languages out there. Let's see, remove, does it return the value? No, it returns whether or not it was in there. Oops, I clicked on bool. Cowface Dude said if I was doing this in JS, it would be at least 100 milliseconds. Yeah, I mean, I think they've got to scale the speed based on the language you use, because if you're using a very slow interpreted language, they should give you more runtime, right? And it's only fair to compare it against other versions. It returns bool. It doesn't actually return the value. I was hoping it would, but I guess that's yeah, that's fine. I can say HS remove array start. Then I can say if array start is equal to array end, then break. Otherwise start plus equals 1. Actually, we want to increment start here, and then we can say start minus 1 is equal to end, if the thing we just removed. And we don't have to insert that there. Oh, wait, that's not going to work. Because we'll need to insert, yeah. I guess there's no other way to do it. Because you still need to insert it. Oh, yeah, so we somehow you need to insert it, because now we can check to see if the array start is equal to the array and not remove it. But somewhere you need to insert it. So my brain isn't quite keeping up with what's going on. Kafka says we could use take, and take would show us. Oh, I see, yeah, removes and returns the value in the set. But no need here, I think. Yeah, because we should be able to look before we insert. But here we want to see if we weren't able to remove it. That's where we want to do the HS insert array end break. I don't know if that's going to work. Well, that's why we have test cases. Yeah, so that worked. Kafka says insert returns a bool as well. Oh, that's a good point. Yeah, because then we could say insert, and if it was already present, the set already contained the value false is returned. Right. I wonder if we could, because this still tries to remove, and then insert. Yeah. I don't know if I'm just playing with this too much, or if this is. How would we do it if we tried to do an insert and check on insert? If not HS insert array end. If we didn't insert it because it already existed, then we have to start popping until we find it. While array start is not equal to array end, HS remove array start. and then, oops. Like that. Let's see if that works. That was a weird reformat on Rust Format's part. Oh, and now I forgot to increment array start, so now we have an infinite loop. Beautiful. Start plus equals 1. So I have to kill this. ps-fu gas target. Nope. Wow. Put the minus in the wrong spot. Kill this guy. Okay. So did I save this? I did. Okay. I saw there was a warning there, and it might have been a warning that start was never used. So that would have been handy. All right. So these tests pass. So that's an even simpler design, I think. And I don't know what's more efficient, max of hslen or max of a start minus n. That should also work. Nope, it failed. And my computer fan is going haywire, so maybe I didn't kill that thing properly. No, it's dead. Maybe it's just delayed reaction. Okay, so start minus n plus 1. Oh no. Subtract with overflow. N minus start. No. Okay. Oh. We should only do this if... Okay. Yeah. Let's leave it as the length of the hash set, because that's the actual value of how many characters there are. All right, let's see if this is any different to the 11 millisecond version. Here, paste, submit. And it gives the wrong answer on this one. Ooh, exclamation point. Okay, let's copy and paste that and see. So the longest subject, oh, dang. Expected a 3, and I ignored the exclamation mark for some reason. Shouldn't. Wrong answer 1. Okay. Oops, oops. Let's do that, let's do that. Let's fix that string. That should be 3, and we're getting 2. Interesting. Why? It shouldn't be the exclamation mark. If I change that to a C, it should be AB exclamation mark, right? If I change that to ABC, yeah, it still says 2. So it's got nothing to do with that character, and everything to do with this bad code. So let's just take a look at the string here and see if we can do it one by one. If not, HS insert. So this should return true. So we should get A in there, n plus 1. We come here. The A should return true, so we should remove it. Oh, because AA. Array start is equal to array end, so it doesn't remove it from the hash set, and it comes up with the... Yeah, well, that's fine, because it leaves the A in there, right? And then we say n plus 1. Now we're pointing at B. It works, and then we hit A, and now we have to remove the A. And we have BA, except we don't remove anything. Okay, so let's maybe we can just print it out as we're doing the work. We can say println found. We can just say found. println removing that array start. And we can take a look. Voltaire Noir says, what's Rust version that LeetCode is currently using? I don't know. Kafka says 1.58.1. Kafka asks, do you need to increase start again after the while array start is not equal to... Oh, maybe. Maybe. Removing A. That shouldn't be, right? Do I have to increment start here? Is that what you're suggesting? Yeah, that's the answer. How do we avoid having multiple increments then? I don't, because there should be a way to do it without the double increment. Yeah, is there a way to find out what version? I can click details, but details doesn't tell me version, and there's no version string that I can access, I don't think. I can change the language. Yeah, nothing there. All right, well, let's try this and see how this goes. Start plus equals 1. Not thrilled with this, but we can live with it. Yeah, so it's about the same time as the previous solution. All right, let's stick with this one. I like this one. Kafka says the I is for information. Yeah, this says editor shortcuts, right? So, unless there's another I I'm missing. No. Oh, this I over here. Oh, I didn't realize that was a separate thing. I think they're getting a little too fancy. Look at that. Also with the bar, it moves the button over. You're getting a little too fancy with the information there. Rust 158.1 and supports RAND version 0.6 from Crates.io. Oh yeah, I guess anything that would need random numbers, you need to be able to pull those in. So it's already part of whatever cargo.toml they're using. Okay. But this is a decent solution. We might be able to get away, we might be able to put a loop in here. No. Yeah, I'm trying to think of how else to do this without having 2 increments on start. And I don't see it. I mean, in C, right, you just say start plus plus here. And you could eliminate both these lines. And then you have to say start minus 1, or here, right? All right, that's a good version. Git status, git add source, git commit -m problem 3, longest substring without repeating characters. All right, let's tick that box. Check that circle. Threesome. All right, given an integer, excuse me, given an integer array nums, return all the triplets nums I, nums j, nums k, such that I is not equal to j, I is not equal to k, and j is not equal to k, and nums of I plus nums of j plus nums of k equals 0. Notice it's a solution set must not contain duplicate triplicates. Oh, duplicate triplets. Sorry. So the thing I think I'm going to write a quick little utility to compare two vectors in any order, because who knows what order these things are going to come out as I go through these examples, and so we don't want to have the vectors be exactly equal. So let's do that first. Right, it's under utils. Hello, source utils mod. I tried to jump to it, but apparently the jump didn't work. Pub mod vec, let's call it. Pub use vec star. And now can I jump to it? I can. Okay, so this shouldn't be too hard, right? All we're going to do is try to we don't want to have it sortable, but we can throw it into a hash set and compare it that way. That might be the easiest way to do it. Kafka says vec of I32 and vec of I32 semi-3. Oh, you mean over here? Yeah, right? I think they're just keeping it as generic as possible. I mean, you should see the list node and tree node are pretty generic. But everything is I32 that we've encountered so far. So we haven't had to worry about generic types. Let's say pub fun vec's equal. How's that sound? And then we just need vecs of, yeah, so these could be vecs of vecs that we want to compare. So I want to be able to say like v1 t, v2 t, and returns a bool if they're equal or not. Kafka says, wait, didn't you do 190 reverse bits? I have not yet done 190 reverse bits. Let's take a quick look at 190 reverse bits. Climbing scares, discuss. When did I look at that? All right, so where's the problems? Here they are. And is there a search? Search, reverse bits. There it is. I don't know if this is coming up in grind 75 later. Reverse bits of a given 32 bits unsigned integer. Oh yeah, okay, so we have U32s there. In Java, the compiler represents assigned integers using 2's complement notation. That, for example, 2 above, I mean example 2 below, the input represents assigned integer -3. Okay. But yeah, no, I haven't done this one yet, but this is pretty obvious on how to do it, right? You just shift right, shift left. We can get rid of that, and we're on this one, and we're going over here, and we just need to compare. I guess we can start off by saying if v1.len is not equal to v2.len, then return false. And that way we know that v1 and v2 lens are the same, and we can create a hash set, right? Use standard collections hash set. We can create a hash set. Let hs equals v1 dot iter. No, we're going to say hash set from iter, right? We can do that. Pretty sure. I just closed the hash set thing, didn't I? Rust hash set from iter. I thought I had it from iter. Maybe that's a more generic. I could have sworn there was a from iter. From iter. There's a B tree set from iter. Kafka says you can collect into hash sets. Okay. So I should be able to say v1.iter.collect hash set of t. Oh, but that would eliminate duplicates, right? Okay, so we don't want to do that, because if there were duplicate items, then they wouldn't, we wouldn't know. All right. The thing is, I didn't want to turn this into an O of n squared problem. What we could do is store all of the, we can do, say this, let mod hs is equal to hash set of from iter of 0 dot dot v1 dot len. So we have all the possibilities of the locations. Is that going to work? It won't let me do that. The visibility is not followed by an item. Oh, because I typed phone instead of phone. Droidman91, thank you for the follow. T, right, I need a T here. Something like that. Collections with too many T's there. That's where the T went. Expected bool found nothing, so let's just say false. And we need to write some tests. Cannot infer type parameter S. Use sizes. Yeah, okay, so now test mod. Test. Let's see, compare empty. So we should say that these compare correct. Vex equal. Oh, and then I'm going to have to give it a type, right? Otherwise, it won't work. We won't be able to infer the type of these guys. Okay, and I'm going to change this here so we can see the test passing. All right, so that's failing. So let's see. If we say for value in v1, we can iterate over the hash set, and which would give us the location of it in v. Oh, yeah. So this doesn't matter, but I'll change it to v2 then, so it's obvious that this is v2. So we can say for h in hs iter. I have to come up with the better variable names. If v2 of h is equal to val, then we found the location of val that's in v1. We found it at h in v2. So we should be able to say I can't do an HS remove here because we're iterating over it. So I need to save the location. Is 0. Actually, I can say it's none. And I can say location is sum h brick. And then if we didn't find it, if location is none, then the arrays aren't equal because we weren't able to find val in v2. If we did find it, then we want to remove it. And here we can actually remove it. Else return false. And then here we want to say we found everything, so we just return true. We know we had to find everything here because the lengths show us that. So if we get through this whole loop and we found every single item, then we're done. Okay, that should work. Of course it doesn't. Slice indices are of type usize, and what am I doing? Oh, I have to put a star. Or I can put an ampersand here. And they have to be partial equal. Okay. Oh, let's see if it could actually work. Flip binary expression. No. Can I do this and here? No, that's the only option, is to flip binary expression instead of doing an insert here of partial equal. Standard compare partial EQ, and for some reason you have to put a reference T in there. Let's just do that and see if we can. That? Nope. Now it's a double ampersand. How about that? There we go. And then we got to remove that. Oh, we're so close. V1 iter. Nope. Maybe if we do that. And then that. There we go. Okay. That's a neat thing about Rust. You just keep throwing on stars and ampersands until it compiles. What else should we do? Compare singles. Vex equal. And this time we shouldn't have to specify a type because it'll infer the U32. Oh, compare equal, assert like this. There. Okay, so the next one, let's compare that they're unequal. Compare one unequal. Assert not vex equal 1 and 2. Okay, that works. And then we're going to compare out of order. Compare out of order. So we'll say they're equal, vex equal, and we'll just create an array of 1, 2, 3, 4, 5, and another array of 5, 2, 4, 3, 1. And those should be equal because they have the same values in them. Yes. Okay. This is brilliant. All right, so we have this now. Git status, git add source, git commit -m, vec comparison utility. Now that we have that, let's go back to this leet sum problem here, and then we can use vex equal to compare these guys. And this is problem number 15. Ooh, it's a low number. Leet lib 0015. 3 sum. I put an extra thing in there. 0015. Oh, now it doesn't work. Great. 0015. 3 sum. There. Paste, and then this is vec new. There, and test mod. Test. First example, solution 3 sum of, and we're going to pass in a vec bang of this list here, like that, and then we're going to compare it equal to, oh, right, vex, use crate, vex equal. So we're going to assert that these two vectors are equal. This one and, let's say, -1, 2. I guess these subvectors, maybe I can just return them in sorted order. Yeah. Oh, I forgot the that. Okay. Expected this, found struct vect. Okay, so oh, I have to do a to vec. I can't just throw this in there. Huh. Oh. Do I have to do that? I guess so. Yeah. Okay, so this tells me which one I got wrong, but it doesn't tell me what this is returning, which is a shame. It'd be nice to be able to do that. But I can worry about that later. Okay, so three-sum. I guess the naive approach is doing the triple nested for loop, right? But we can do better than that. I remember doing better than that in a advent of code problem. But let's just do the naive version first. For I and 0 dot dot nums len minus 2. Ooh. Do we have a constraint of at least 3 numbers? Yes. Okay. Otherwise that would panic. For j in I plus 1 nums len minus 1. For k in j plus 1 dot dot nums len. If nums of I plus nums of j plus nums of k is equal to 0. So this is O of n cubed. Oh, right. I wanted to return these sorted so that we can compare these properly. That might be equals, vec bang, nums I, nums j, nums k, v dot sort, result, which I haven't created yet, push v. Right, and then result is just going to be a vec of, let's say vec new, and let it figure it out. It did, good. And I got a return result. Okay. The test did not pass. This is where we need to actually get the result, but I guess we'll do it this way. What do we got? Oh, we have a duplicate. Right, because there's 2 different negative ones. So there's 2 different ways you could do negative 1, 0. I guess based on what we're expecting, we don't want duplicates. Ah, yes, right. Notice that the solution set must not contain duplicate triplets. All right. Then use standard collections hash map hash set. And we can say hash set new. And we can say result insert. And then we say to Raging Lunatic, thank you for the follow. Glad you joined the stream. Result iter collect vec I32. Let's see if that works. It does not. Oh, because I missed there's too many of these things. Oh, maybe we can say into iter. Can we do that on a hash map, a hash set? We can. Okay. So yeah, I think this is going to be too slow because it's O n cubed. But let's give it a shot and see what the input is that it fails on. Look at that. Time limit exceeded. Yeah. So let me do a view all. Wow. I'm going to save this. Lead code threesome input.txt. Oh, I just want to save the, let's just, maybe I can save it here. This would be kind of crazy. Test, boom. Wrong answer 1. Let array equals paste, semicolon. How long is that? 19265. Wow, okay. And if I do that, and now it's formatting it. Oops, I should have waited. Deraging Lunatic says, I've been learning Rust for about a month or more now. Aim to make games as well. Just wondering what game engine you're using. I have been using bracketlib and Bevy. And now my thing is stuck. Reformatting. That was a mistake, wasn't it? There's a way to do includes, right? So I should be able to... I can't kill this either. Okay, I'm going to kill it here. Let me look right here. pkill and vim. Okay. And who knows what state my... Oh, I want to actually go to threesome, which is here. Uh-oh. Is it gone? Is that file gone? It shouldn't be. Here it is. Oh, it just never saved that. Okay, so what I can do, I should be able to say, oh, I can't go. There we go. View page source. I should be able to say save the page source, right, as big array.txt. There we go. And here, maybe I can read it in. Wrong answer 1. We can say let, oh, yeah, I don't want to have to parse it. There's a way to include text, right? Rust include bytes. Yeah, so if I move that here, download, it was called big array.txt here. Include string? Yeah, that sounds even better than include bytes, right? Will it parse the includes UTF encoded file as a string? So let's see if that works as a let array equals include stir big array.txt. We could say println array.len assert bang false, and then we can see it. Oh, do I need to do I need to include it somehow? Should I say standard include? No. Standard macro. I don't think I have to do anything. I thought it would be part of the built-in things, but did I typo it? Include stir. No? Oh, the file name is relative to the source file. Thank you, Kafka. Yeah, so okay, there's 42,000 entries in that array. Okay, so now what we can do is try to do a threesome on that. that will take a while, won't it? So then that'll give us the incentive to speed this up. What was the expected? Oh, it doesn't show us what the expected answer is. Well, we could just put something in there and see what happens. Assert. I don't know. Let's see if there are no entries in it. Let count equals 3 solution 3 sum of array dot len, and that'll tell us how many there are, and then we can just say assert eq count is 0, and it'll tell us how many there are. Okay, and is this running? I can't tell if it's running. Oh, expected struct fact found stir. Oh, because this is a string. We have to parse the string and then convert it into an array. Okay, how about this? Vim big array. Oh, that's not good. That is not what I was expecting it to be. Let's get rid of that. Copy, and what I'll do is I'll go here and come on, there we go. Okay, I guess we could just leave it like that. It's wrapping. It would be nice if I could somehow get this to wrap. But it won't wrap. So, all right, I have the array if I want to ever use it. But you know what we can do is we can ignore this whole thing. There we go. And just do a better answer. Right, and the better answer obviously is going to be not involving doing an O3. We can get O(n) cubed rather. We can get it down to O(n) squared. Just by mapping all of the values and then doing an O(n) lookup for the remaining values. So if we can say we have a hash set, we want a hash map as well. Let's see if we can do it this way. Let hm equals hash map new for index and value in nums iter enumerate hm insert val idx. Okay, so that gives us, we can use a value and look up the index of that value. Because we need to make sure that it's not equal to the I or the J that we're finding. That's the only reason I'm doing it that way. I in 0 dot dot nums len minus 1, or J in I plus 1 dot dot nums len. The value we're looking for, because these have to sum up to 0, is going to be negative nums I nums j. Right? And if that value is in the hash set, which I'm going to have to look up again, hash set entry occupied in hash brown, not hash brown. I don't want hash brown here. Entry what? That's not what I wanted. There is a, oh, am I in hash set? I'm in hash set. Hash map. There we go. Entry. Perfect. Okay. And then we want to get the entry occupied. Right. Okay. HM entry of val. So if we can find the value in the hash set, then we know that entry has to be not equal to, oh, what is this? How do we, I want to get the actual value. Oh, it says unknown. Oh, I have to import it, right? Hash map entry, if I remember correctly. Yeah, oh yeah, it's right here. Duh. Okay, so now, will it tell me the type? It will. It's an occupied entry. Perfect. And an occupied entry has a get function on it. It gets a reference to the value of the entry, and the value is our index. Okay, so if I is not equal to entry.get, and j is not equal to entry.get, that means we found a unique solution that val, or idx is equal to entry.get. So we found a unique solution, and now we just do the same thing we did up here. These 3 lines. Right? Close, 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 close. Get rid of the print. And that fails completely. Oh, not nums of k. Now it's val. We can't apply, oh, that was supposed to be a plus sign. Why did I put a comma there? Found ampersand u size, okay. All right. All right, now all the tests pass. That's good news. Let's see if we can throw this in there. Well, let's get rid of that solution. There we go. Paste. So it's a little longer, but now we're down to O of n squared plus O of n, which is O of n squared. Okay, that's pretty slow. 1374 milliseconds. Kafka says you can drop the type from the return because it's already specified. Good point. Yep, that works. And all 89 tests still pass. What else can we do to clean this up a little bit? Yeah, so this basically says we're looking for a value of the complement of the sum so that everything, so nums of I plus nums of j plus val should equal 0. And if we find it and we're not reusing I or j, then we're going to put nums of I, nums of j, and the value that we inserted here, and then we sort it so that we can test it properly. I don't think I did the other test, right? There was another one? Yeah, let me throw those 2 tests on there just for completeness. And then we can commit this change. Assert EQ, assert vex equal, solution, 3 sum, back bang, 0, 1, 1, comma, and it should be an empty array. Let's see if that will I compile. That should be x2. And then ex3 is vex equal solution 3 sum back bang 0, 0, 0 should equal 0, 0, 0. Something's wrong there. There. And that failed. Why? Oh. Like that. There we go. Okay. So now I'm happy. This is my solution. Get status. Get, oh. Yeah, we're going to remove big array. We don't need that. Git add source. Git commit dash m problem 15 3-sum. That's all it was called, right? 3-sum. Good. Okay. We've got 2 down. Now we have binary tree level order traversal. Let's see what that's about. Given the root of a binary tree, return the level order traversal of its nodes' values, i.e. from left to right, level by level. Okay, so it's kind of reversing what we did before to create a tree. And this is problem number 102. Oh, 102, binary tree level order traversal. Obstruct solution paste vec new test mod test x1, and we're going to say use, oh, we have to put this up here, use create tree node. So let tree equals tree node from vec bang this. And then we want to assert. Oh, this is where it comes in handy to get. Okay, so it's interesting. We're building up the array just by level. So all we need to do is recursively build the tree and then pass down our current level, and then we can also pass in a reference to an array to build. Okay, so that should be straightforward. And the order matters here. So we don't need to use the vex equal. We can just assert that solution level order of tree. Oh, some RC new ref cell new tree is equal to this output. That's all we need to do. And that should fail. Oops, it failed the wrong way because I forgot that we have to convert the nulls to i32 min. Oh. Okay, we're getting closer. Oh, this is already an option? Oh, it is. Okay, okay. True. I forgot. Comma. And then these need to be vex, right? Vec bang, vec bang, vec bang, and vec bang. Okay. So I think we want a separate function. We can just call it level, which takes basically this except I want to pass in a reference. This is a solution pattern I've done before. And it's also going to take in whatever the current level is. Maybe I shouldn't call it level and level. Let's call it do level. and then the result vector, which is going to be a vec of I32. Actually, we want to make it a mutable reference to that, right? Because we're going to actually insert it. So if vec.len is less than a current level, then it should be equal to level -1. Because what I'm going to do here is I'll just call it with 0, do level root 0, and then our result. Let result equals vec new result, and then just return result. Right. So we're going to start off at level 0. The vec.len is going to be 0. Okay, so it has to be less than or equal to level. So we pass in this. If vec.len is less than or equal to level, it should be equal to level or level -1. It should be equal to level, right? Because what I'm going to do is I'm going to actually, vec push, vec new. It should be able to infer the type. And then the vec. Oh, what am I doing? This should be a result. I keep thinking vec. Result of level dot push root borrow val. And then we want to do the left and the right. So we're going to basically push for this current level. And as we go down, we could say self do level. And this will be a reference to node root borrow left. Then the next level, which is be level +1, and then continue to pass that in. And then right. So all we do is push the current level on the current value on the current levels list, whatever that is, wherever that is in the array, right? So if we look at this example here, first time we're going to call it, we're going to push an empty list, then level is going to be 0, and we're going to push the 3. Then we do the left tree. So level +1 is 1, and we pass in that same result. So it should see the 9, and push that. Result len should already be 1. Oh no, it'll be 0 because we're at the next level, right? Because level's 1 and result len is 1. So we push a new thing. We push for level 1, we push 9. Then it goes to the right tree with level +1. Result len, now it should already exist. At level 1 should already exist on that result. So then 1 gets pushed there, 1 gets looked up there, and then the current node, which is 20, gets pushed. So then we have the 9 and the 20. And then each one of those do the left and, oh, oops, I need to check if root is none. Oh, let's do it differently. Let's do it this way. If let some node equals root, right? Because I have to undo all these options. Then we can do that, and then change these roots to node, right? And then if it's a none, then we just skip it. Outbound in the scope self. Types different immutability. I guess I put a mute there. Oh, okay. Yeah, that's one of the things about binary tree solutions is that they don't really need a lot of work. You just think about, okay, just do it for the current node and the left and the right, and then you have the answer. Let's do example 2. X2, let tree equals tree node from vec bang, it's just 1, and then we want to say solution level order of tree is equal to vec bang 1. Okay. And then test ex3. And now we have an empty tree. So solution level order of none should equal an empty array. And it doesn't. What did I do wrong? Oh, we need a type. We need type information. Cannot infer type. And I don't know how to give it a type. Vec new I32. V equals vec bang 1 v dot pop. That's bad. No implementation for this. Oh, vec bang. Oh, yeah. So none should return an empty, and it does. And I'm checking against that. Okay. And I can't do that, right? Can I do this? Cannot infer type. So I don't know how to test this last one. But I'm sure that their code will test it. So let's throw this in here. One millisecond. That's pretty good. So they must have tested it. So let's just do it by eyeball. If this is none, we pass in a reference to the none. This does nothing. So that means this vec new just gets left alone, and it just returns an empty vec. And so we're done. So I think it would work. I just wish I could figure out how to assert. Maybe I just need to assert that it is none. No. It is empty. Let's try that. Yeah, okay. That passes. All right, let's do that. Git status, git add source, git commit. Problem 102, binary, tree, level, order, traversal. All right. Circle gets a square. Boom. Clone graph. Give it a reference of a node in a connected undirected graph. Return a deep copy of the graph. Each node in the graph contains a value and a list of its neighbors. For simplicity, each node's value is the same as the node's indexed. For example, first node with val equals 1, the second node with val equals 2, and so on. The graph is represented in the test case using an adjacency list. An adjacency list is a collection of unordered lists used to represent a finite graph. Each list describes the set of neighbors of a node in the graph. The given node will always be the first node with val equals 1. You must return a copy of the given node as a reference to the cloned graph. You can't return the same graph. That makes sense. The nodes are cloned, but the graph is messed up, doesn't have the same connections. This is the adjacency list. So 2 is connected to 4, 1 is connected to 3, 2 is connected to 4, 1 is connected to 3. And we just output the same exact thing. Wait, I don't understand this. 1's connected to 2 and 4. Unordered lists used to represent a finite graph. Each list describes a set of neighbors of a node in the graph. So I don't understand the input format at all. Maybe I'm just not up on my graph theory. But you'd think that these neighbors, so you'd have like graph 1 would have 2 neighbors. Oh, I see. So this index 0 is graph node 1 and it has neighbors 2 and 4. This is index 1, so it's graph node 2 and it has neighbors 1 and 3. And then 3 also has 2 and 4, and 4 has 1 and 3. Okay. And we just need to copy each one and then make sure that they're cloned appropriately. And so when we create one, so that's what we use. We start off by creating 1. We create 2 and 4 for 1. Then when we do 2, we have to backlink to 1 because 1 already exists. And somehow we need to know that. And then create 3. Then on 3, 4 and 2 both exist, so 3 has to link to the existing 2 nodes that have been created. And then 4 has to do the same thing, has to find the 1 and 3 that's already existing. And then link everything up. Make sure those neighbors are correct. All right. I think I understand. Why is this saying C? Oh, there is no Rust. There's no Rust version of this. What does the C version look like? Okay. So the last time we encountered this issue, I was able to just throw together a quick C solution, and I did it right here in this editor. I think this is more complicated and probably is not going to be a good thing for me to do on stream since this is meant to be a Rust stream. Yeah, maybe we skip this one and I'll come back to do it later. Kafka says that's probably why they didn't do it in Rust. Well, I mean, you can use RCs and ref cells to have multiple links to things, right? I guess you'd have to know, maybe you'd have to know about weak references and things like that. Because I can do RC to, I can have 2 RCs to the same node. I wonder if we just do it in Rust and figure out how to do it in Rust, but that wouldn't be good stream material. All right, let's set this one aside, and we'll come back to it later. Evaluate the value of an arithmetic expression in RPN. Valid operators are plus, minus, star, multiply, and divide. Each operand may be an integer or another expression. Note the division between 2 integers should truncate towards 0. Okay. It's guaranteed that a given RPN expression is always valid. That means the expression will always evaluate to a result, and there will not be any division by 0 operation. All right. There should be a Rust version of this. This doesn't sound... Yeah. Okay. So we just take tokens. Oh, the tokens are strings. Interesting. So we get the inputs. We have to parse these, convert them to operations, and then just perform the operation. Okay, so this is, RPN is super easy with a stack, right? So this will be a lot easier than trying to struggle my way through the graph cloning thing in C. What I'll do off stream is I'll get my environment set up for a quick C thing, and we can try it out. What's the problem number? Is 150. Oh, 150 evaluate inverse Polish notation. Okay. Paste.
Esta cosa. Pero por ahora lo voy a dejar. Sí, lo voy a dejar así por ahora.
right. Good morning. Welcome to my stream. Let's see if we can get going. Switch over here. There we go. All right. So where did we leave off last time? Oops. Okay. I think we're here. We're here. Oh, we want to check out where we were. So we just finished k closest points to origin. We did that. And now we're up to longest substring without repeating characters. Okay. Where's my mouse? There it is. Oh, I got a train in the background. I'll wait till the train's done before I start. All right. I think that's good enough. All right. Longest substring without repeating characters. Let's, this is clean, right? We're clippy clean and we're test clean and everybody's clean. Okay. So, and it just shows clean. Good. All right. Problem number 3, longest substring without repeating characters. Oops. Given a string S, find the length of the longest substring without repeating characters. Oh, that's all it is. Okay, so input is ABC, ABCBB. Output should be 3 because ABC is the longest substring. Here, B is the longest substring without repeating characters. And then we have WKE. Notice the answer must be a substring. PWKE is a subsequence and not a substring. Okay, because it's a double W. All right. Well, let's get things set up before we come up with a solution. But this doesn't seem like it's too difficult. Let me just change the volume here again. It's a little too loud for me. All right, that's better. All right, so this is 0003. Right? Longest substring without repeating characters. That is very long. Is that the longest one we have so far? Oh, this is close. Let's see. I'm just curious now. That goes to 63. And that goes to, so it's the same length. Okay. All right, so we try to build. We then do the quick action to create the file. We then jump to that file. We then grab this, copy, pub struct solution, paste, and return 0. And then that should also build. It does. I'm looking over here to see if it's building or not. And then we have our test. First example is going to be solution length of longest substring for, and it's looking for a string ABC, ABCBB, toString, and that's going to be equal to 3. And that should fail. Oh, test. There. And it fails here. Good. Okay. So the first thing that comes to mind is using some sort of using a hash set in some fashion in order to keep track of what characters we've seen before, and then just keep a list of all the unique characters. So like if we add A to a hash set, and then we add B, and then we add C, and then we go to add A, but A already exists in the hash set. We can't just remove it and keep going. We actually have to remove it in order. Right? We have to remove, because once we get to this B here, right, well, it'll be A, B, C, B. We want to remove the A and the B from the substring, and it'll be CB. And then we want to keep track of the length of the longest one that we've encountered so far. Okay, so we know we need a hash set because that's the way we're going to look things up. So use standard collections. Oh, I shouldn't be writing it here. I should be writing it over here. Use standard collections hash set. And then we'll need an array, which is s.char is collect vec.char. Right, so now array should have a list of all the characters, and we can actually go through each array element. So I guess we'll start with a start and an end pointer, and then we move the end pointer forward until we find a character that we've seen before, and then move the start pointer forward, removing from the hash set until we've removed the character that we encountered. Okay, so our hash set is just going to be start off as empty. Kafka, how are you? Yeah, I try to stream around the same time every day. So if it's a bad time for you, then that's gonna unfortunately be the bad time every day. But glad to see you today. Let's see. If we start off by just inserting, we can do, so let's start and end values. Let start equals 0, let end equals 0. And we can say while end is less than array len. We want to look it up in the hash set end, right? If hs contains array of end. Kafka says it's fine, just me being too busy. Yeah, I know how that goes. There are many mornings that I can't stream even though I want to, because of various life things. So if the hash set contains, all right, so we're going to assume that we've gone through A, B, C, and now we're on the second A, and we see it there. We want to remove the first entry from the array, starting with start until we no longer have it in the array. I guess, yeah, so what we can do is we can make this a while. While hs contains array end, we can say hs remove array, array start. BJ, thank you for the follow. Much appreciated. Glad to see you. And then start plus equals 1, right? And that way we'll keep removing until we hit the beginning, the first one that doesn't have array end. So now we'll have an actual array length. VJ says roses are red, violets are blue, lead code is cool, VJ follows you. Very nice. So now we want to save the length of the array. So we need a max len. And we want to say the length, I guess, is the number of characters in the hash set, right? So we can just say max len equals max len dot max of hs len. Because the number of characters in the hash set is the number of, it should also be equal to start minus end, right? Oh, we got to insert hs insert array end, because we've just removed it, right? We just removed array end from the hash set. Now we're going to reinsert it. I guess that's kind of sloppy. Maybe but there's no other way to know it. Unless we say hs remove array start and then check to see if it's equal to array end, and then we can just ignore that insert. But that's starting to feel like premature optimization. Let's see if this version works. And then I think that's all we need to do. And then once we've figured out which one is the one that has the most characters in it, That's our result, right? Oops. Okay. What else? That also has to be a reference. I keep forgetting that. And then this needs to be an I32. Is that it? No more items. Okay. And this fails because I'm off by 1. Nice. I'm off by 1. Oh, we want to include the end. Okay. So let's do that. How's that look? Yep, that looks better. And then, oops, example 2 is BBB. Let's see if that one works. Y, paste. 1, 2, 3, 4, 5, and that should be a 1. Yep, that works. And then we have this one, whatever that is, PQQ. EX3. That one, and that should be a 3. Okay, so I think we have a working solution. We might make it a little more efficient by not removing and then inserting right away. But let's see how bad this is. I'm being judged. Okay, not too bad. 35%. But again, these runtimes are kind of wacky. All right. Can we actually do that? We can say, while HS contains, okay, so we don't want to actually do that while HS contains. If we don't want to avoid inserting the same character we just removed, we can say loop HS remove array. Doesn't the hash set remove give us Rust? Rust. There's too many languages out there. Let's see, remove, does it return the value? No, it returns whether or not it was in there. Oops, I clicked on bool. Cowface Dude said if I was doing this in JS, it would be at least 100 milliseconds. Yeah, I mean, I think they've got to scale the speed based on the language you use, because if you're using a very slow interpreted language, they should give you more runtime, right? And it's only fair to compare it against other versions of that language. So remove only returns bool. It doesn't actually return the value. I was hoping it would, but I guess that's, yeah, that's fine. I can say HS remove array start. Then I can say if array start is equal to array end, then break. Otherwise start plus equals 1.